morning students. Chapter 4 Moving Charges and Magnetism. In last lecture we have discussed how to convert galvanometer in ammeter and galvanometer in voltmeter. Okay, yes, again. To convert galvanometer in ammeter we have to connect shunt, means very small resistance, in parallel with galvanometer. It becomes ammeter. Resistance of ammeter very small. For ideal ammeter its resistance is 0. How to convert galvanometer in voltmeter? You have to connect a large resistance, series resistor, in series with galvanometer. Okay, and thus resistance of voltmeter becomes more. Okay, for ideal voltmeter its resistance is infinite. Now in today's lecture we will see some questions based on this ammeter and voltmeter. Okay, see example 4.13. You are given a circuit, a cell of EMF 3 volt having internal resistance 0, external resistance 3 ohm, and yes, to find current what is flowing from this 3 ohm, a galvanometer is used. So if we use only galvanometer, then what is current flowing from circuit? First of all, to find current flowing from circuit, you have to find what is equivalent resistance. Okay, what is equivalent resistance? Equivalent resistance. What is equivalent resistance here? So yes, it is obviously R is equal to, it is 3 and G. This 3 ohm and this G, they are in series connection. So yes, it is 3 plus 60 is equal to 63 ohm. Cell of EMF 3 volt. So what is current I? Current I is equal to, it is 3 upon 60. Current I is equal to, it is 3 upon 60. If you calculate this, you will get 0.048 ampere. Clear about this? So yes, current flowing is very small. Now, what is question B? If this galvanometer is converted in ammeter by a shunt, S is equal to 0.02 ohm. So what is meaning of this? See, here it is. Resistance, this galvanometer, this shell. Okay, this circuit is 3 volt. It is 3 ohm. It is 60 ohm. But what is meaning of this? Converted in ammeter by a shunt means to convert in ammeter you have to connect shunt parallel to it. You have to connect shunt parallel to it. Clear about this? So do you understand this figure? Okay. So first of all, S it is given 0.02. First of all, we will find what is equivalent resistance. See, this G and S, they are in parallel connection. So yes, what is answer of G and S, their parallel connection? It is GS upon G plus S. G is 60, S it is 0.02 divided by, it is 60 plus 0.02. If you multiply this, you will get your answer, it is 0.02. Okay, now this 0.02 is in series connection with this 3 ohm. So equivalent resistance R is equal to this 3 plus 0.02 means this 3.02. So now what is current? I is equal to, it is battery having 3 volt, total resistance is 3.02. So if you calculate this, you will get your answer 0.99 ampere. 0.99 ampere. So what is meaning of this? Actual current flowing. We want to find what is actual current flowing from this 3 ohm. It is 0.99 ampere. If we use only galvanometer, then see this current changes. 0.98 means it is 0.1 nearly, but it is, see, like this. Clear about this? Okay. Now, third question. Is an ideal ammeter with 0 resistance? Ideal ammeter means what? It is 3 ohm resistance. It is ammeter, battery, 3 volt. It's 3 ohm. Ideal ammeter, so its resistance is 0. Its resistance, ideal ammeter, its resistance is 0. Okay, so yes, here how to find current? The current flowing from circuit, I is equal to, it is only 3 upon 3, means is equal to, it is 1 ampere. Means is equal to, it is 1 ampere. Clear about this? See, what is difference between these two? They are nearly same. But when we use only galvanometer, we will not measure. We cannot measure actual current flowing from it. We cannot measure actual current flowing from it. Clear about this? So yes, in question A, only galvanometer is used. In question B, that galvanometer is shunted by 0.02 ohm. And in question C, you have to take an ideal meter. So in each and every question, you can compare answers. Okay. Now, next question, that is exercise 4.27. What is given? See, here it is. You are given a galvanometer. You are given a galvanometer having resistance G is equal to 12 ohm. Having resistance G is equal to 12 ohm. Resistance of galvanometer is 12. And this galvanometer shows full scale deflection for current 3 milliampere. So what is meaning of this 3 milliampere? Again, galvanometer shows full scale deflection for 3 milliampere. Means it is current capacity given. Ig 3 milliampere is equal to, I can write 3 into 10 raised to minus 3 ampere. Clear about this? Okay. Galvanometer to be converted in voltmeter of range 0 to 18 volt means I want to measure voltage 18 volt. I want to measure voltage 18 volt. Clear about this? So now how to convert galvanometer in voltmeter? Yes, you know. Okay, to convert galvanometer in voltmeter, I have to connect one series resistance. I have to connect one series resistance. So yes, to convert galvanometer in voltmeter series resistance RS is connected. RS is connected. Okay, so now this system pole, it becomes as voltmeter like this. Okay, it is voltmeter. Okay, then yes, we have to find what is value of RS. We know its equation. RS is equal to, it is V upon Ig minus T. V upon Ig minus T. So yes, is equal to V. What is maximum value? It is 18 divided by what is value of Ig? Yes, it is 3 into 10 raised to minus 3. And what is value of G? It is 12. So it is 3. Here it is 6. Yes or no? Yes. So it is 6 into 10 raised to 3 minus 12. So yes, here it is 6, 0, 0, 0 minus 12. Clear about this? Clear about this? Okay, any doubt? So yes, 6000 minus 12. You can easily find your answer. You can easily find your answer. What is answer? Yes, it is 5988. Oh, it is 5988 about this. Clear? Clear? So yes, to convert galvanometer in voltmeter, you have to connect one series resistance having value 5988 ohm in series with galvanometer. In series with galvanometer. Clear about this? Clear about this? Okay, 6000 minus 12. Yes, it is 5988. It is 5988. Okay? Okay? So yes, this much amount of resistance you have to connect in series. Now one similar question. Yes, in previous question we have converted galvanometer in voltmeter. Now question is you have to convert galvanometer in ammeter. What is question C? A galvanometer having resistance 15 ohm shows full scale deflection for current 4 milliampere. So yes, Ig current capacity is 4 milliampere is equal to 4 into 10 raised to minus 3 ampere. Clear about this? Okay. Convert, we want to convert galvanometer in ammeter having range 0 to 6 ampere means current flowing is, it is 6 ampere. We know that to convert galvanometer in ammeter, we have to connect shunt parallel to it. We have to connect shunt parallel to it. So yes, you have to write statement to convert galvanometer in ammeter shunt is connected parallel. Shunt is connected parallel to it. Parallel to it. Okay. So now what is value of shunt? Yes, value of shunt S is equal to, it is Gig upon I minus Ig. It is Gig upon I minus Ig. Yes, you are given each and every value. G, it is 15. Ig, what is value of Ig? It is 4 into 10 raised to minus 3 divided by I, it is 6 ampere, and Ig means it is 4 into 10 raised to minus 3 is equal. See, you can simplify this easily. 5 into 10 raised to minus 3 means 0.005. Simple. Okay. 6 minus 0.005. Simplify this. 15 into 4 is 60. Divide this. You will easily get your answer. And yes, this answer of S will be very, very small. This answer of S will be very, very small, because we know theory. To convert galvanometer in ammeter, we have to use shunt. And what is value of shunt? Very, very small. While in voltmeter, what is value of series resistance? Very, very large. It is 5980. It is 5980. Clear about this? Okay. So yes, how to convert galvanometer in ammeter with the help of one shunt in parallel connection. Okay. So yes, G15 Ig, it is 4 into 10 raised to minus 3. I, that is 6, and Ig means 6 into 4 into 10 raised to minus 3. So how to simplify this? You can easily find. Next question is exercise 4.10. Exercise 4.10. Yes, you are given two moving coil galvanometers. For first moving coil galvanometer, resistance 10 ohm, number of turns 30, area of loop 3.6 into 10 raised to minus 3, magnetic field 0.25 Tesla. While in another coil, resistance 14 ohm, number of turns 42, area 1.8 into 10 raised to minus 3, magnetic field 0.50. Spring constants are identical, means I can write K1 is equal to K2. K1 is equal to K2. Clear about this? Okay. What is question? Find ratio of current sensitivity and voltage sensitivity. Current sensitivity and voltage sensitivity. How to find? See, here it is. Here it is. For first coil, what is current sensitivity? Current sensitivity. What is the equation of current sensitivity? If you know, current sensitivity means phi upon I of 1 is equal to phi upon I of 1 is equal to, it is N A B upon Q. It is equation of current sensitivity, but it is for first coil, so N1 A1 B1 K1. Clear about this? Similarly, for second coil, what is current sensitivity? Phi upon I of 2 is equal to N A B upon K. So it is N2 A2 B2 K2. Simple. Okay. What is voltage sensitivity? Voltage sensitivity. What is voltage sensitivity? Voltage sensitivity means it is phi upon I of, phi upon V. Phi upon V of 1. What is equation of voltage sensitivity? It is N A B upon K R. N1 A1 B1 K1 R. This simple. Okay. Then what about phi upon B for 2? Here it is N A B upon K R. N2 A2 B2 K2 R. You have to find the ratio. Ratio means first question A is phi upon I of 1 divided by phi upon I of 2. Phi upon I of 2. Take this two ratio. Then yes, you will get N1 A1 B1 upon K1. Phi upon I 2. Yes, it is in denominator, so I can write this term like this. It is K2 divided by N2 A2 B2. Simple. Yes, K1 and K2 they will be cancelled out. N1 A1 B1 you are given. N1 A1 B1. You can easily find that ratio. Clear about this? Okay. So what is second question? Find ratio of voltage sensitivity. Then yes, it is phi upon V of 1 divided by phi upon V of 2. What is phi upon V of 1? It is N1 A1 B1 upon K1 R1. into this term I can write like this. It is K2 R2 divided by it is N2 A2 B. It is N2 A2 B. See here. You know what is actually value of this K1 and K2 will cancel out. So yes, you know value of N1 A1 B1 upon N2 A2 B2. From this question number 1, you have to just multiply R2 upon R. So yes, you do not have to calculate another time. Okay, you know answer of N1 A1 B1 upon N2 A2 B2. So yes, you can easily find because in the K1 K2 cancel out, K1 K2 cancel out. So yes, it is one question that you can easily find. Clear about this? Yes, students, see regular videos, make your notes, solve your doubts, give regular exam, and yes, do like, share and comment.